Okay, guys, of grade 11, good morning. Today, inshallah, we're going to talk about section 2, the solution processes of chapter 12. So, we still talk about the mixtures and solutions and so on. So, in the last section, we discussed the different types of mixtures, solutions, suspension, colloid, and we know what the difference between them. So, today, mainly, we're going to talk about solution. Solution is the homogeneous mixture in which a solid completely dissolved in a solvent. So today we're going to talk about the solubility process, or what is how solution is formed, or what happens, what are the factors that could affect the rate of the solution, or that mean the dissolving substance. So once we add a solute to a solvent, regarding to the type of solute and the solvent, okay, we could find that the dissolving process take different time or take different rates. For example, when you add a piece of salt in a cup of water, it take different time rather than a piece of sugar. If you add salt to another solvent except water, it may take a different time. So here we're gonna find that dissolving material actually have different rates, depends on the solute and salt. But also there are some other factors that could affect the rate of solubility. The first factor, which is the surface area of the solid. What does it mean? To represent the idea of the surface area, just look with me carefully here, guys. If we have this cup of water, okay, and that's cup of water, and both are exactly the same, they contain the same amount of water, which, for example, they are 100, okay, milliliter, okay, of water. And then we add here a cube of ice, this cube of salt and ACl. This cube of salt approximately about 3 grams. Okay, for example. And here we're gonna add also 3 grams of salt, but actually in small pieces or in powder. So both are added to the water. Okay, so what do you expect? Which one will dissolve first? Case A or case B? Okay, so actually we're gonna find this will dissolve faster. Okay, so why, although they are the same amount of solute dissolve in the same amount of solvent, why this powder dissolves faster than this cube? Because simply here we say this powder has more surface area exposed to dissolving. What does it mean? It means here, once we have this cube of salt, so once we add it to the water, only the surface area, that means the 6 sides of the cube, will be in contact with the water molecules. So that means the first layer must dissolve first, then pass to the second, then to the third, until the entire cube completely dissolve. So that of course takes time. But imagine if we get this cube, okay, and we just divide it into half, two pieces, okay. So instead of just 6 sides of cube that we're exposing to the water, we are going to have 12 sides, which we get more sides to be in contact with fresh water or to be in contact with water. So like this, the process of dissolving will happen faster. And if we just dividing more into another two pieces, so in that case we're gonna have about 24 sides. So the more we break this is the solvent or turn it into small pieces, the more sides that will be in contact with the solvent, so the dissolving process will happen faster. So like this, grinding or smashing or just using the solid in form of powder make the dissolving substance happen faster, because like this we increase the surface area which is exposed to the solvent. So like this it could break down easily or could dissolve easily, rather than big cubes or big pieces. So that is the first factor that could affect the rate of dissolving or make that so it could happen. So here let's pass to the second one. The second one, which is the agitating a solution. What mean by agitating? That means just moving the component of the solution, or just make the particles in higher move or in more movement than usual. For example, let's see here. Once we get this cup of water, and we just add a piece, some salt in this cup of water. If we just add the salt and you left it like this, it will take just a few seconds until it, or it may be take some seconds until they completely dissolve. But if you just put here a glass rod or a spoon and you start to stir it, So you start to stir it, okay? What would happen? You observe that it's going to dissolve faster. Or if you are just shaking, okay, the substance, okay, so by shaking the substance, that also will cause it to dissolve faster. So what happens here? Simply, if we just gonna get a closer look in that area, we're gonna find that the water particles, okay, they start to dissolve the salt, and the salt start to occupy the spaces between the water particles. So the sodium and chlorine start to fill the spaces between the water particles. So the other solid, the other salt which is still found down here, regarding to this, the space is now somehow is occupied, doesn't have enough space to keep dissolving. It need the time until the particles, these particles move away and the new empty particles get down to keep dissolving. But steering, because these particles to move faster and faster and providing more fresh solvent toward the solute, which means some empty spaces between the solvent particles. So like this, the solute could find spaces between particles or water molecules, so it easily could break down or could to dissolve and pass between these spaces. So like this, stirring, shaking, doing the same idea. It allows the solute to dissolve faster and faster, like that. Okay. So here also, okay, that's here another factor that could affect the rate of dissolving. So first one, the surface area of the solid. Second one is ignite. I am moving the solid, and that especially happen in the higher concentration of solid. That means when you have a lot of solid in a certain amount of solvent. So always you need to stir or shake to ensure that the solvent is moving, okay, with the solid to provide enough spaces for solid to be broken down or to be dissolved in. So here that the second factor. Let's pass to the third one. If you got a cup of water, okay, and you put some salt in, okay, so they are about 100 milliliter of water and about 5 gram of salt, okay, and that is cold water. While on the other hand, you get the same cup, okay, and you add the same amount, also 100 milli of water and the 5 gram of salt, but in a state of cold water, it's hot water. Okay, so what do you think? In which case the salt will dissolve faster? Okay, so of course, in the case of hot water, it will dissolve faster. Why? Because simply hot particles or the hot water, the particles now get more energy. So the particles will just move, okay, quickly, or they are just moving high speed and they move randomly. This random movement allow, okay, the particles to collide more often, which cause, okay, that solute to have more spaces between the particles to dissolve in and allow the particles to break down easier. So like this, we could find that dissolving happen faster in case of hot solvents than the cold solvents. Okay, that's why even that you can find you are making that in your natural day or daily life by sense. For example, when you try to remove some dirt from your cloth or a dish or something like this and find it's hard to be dissolved with cold water, you try to use hot water because it seems by logic that hot water easier to break down or dissolve substances than cold one. So like this, the hot solvents, okay, make the rate of dissolving faster than the cold one. So here, like this, guys, that three factors that affect the rate of solubility or the rate of dissolving of solute in a solvent. That's beside the amount of solvent and the amount of solute, of course. So here, regarding after that, let's hear, guys. Sorry, let's hear. Continue the part. We're going to talk about the solubility process. So, what is solubility process about? It's actually solubility process. It means the process of dissolving, in which the particle of the solid is going to break down into smaller particles, whatever they are going to be charged ions in case of ionic compounds, or even smaller particles in case of covalent compounds. They're just going to break down into smaller particles. This particle is going to fill the spaces between that solvent molecules. Okay, but the idea here, okay, that you need to just clarify this. So here, regarding to this, guys, the solubility, as we said, the breaking down of the solute into smaller particles that is gonna spray it between the particles of the molecules of the solvent. we need to talk about something here. If you just look with me here, guys, if you got a cup of water and you add some salt or some sugar, for example, let's make sugar here. So what would happen? This sugar will dissolve. What I mean by dissolve? It will break down. That means turn into smaller pieces, small particles that will hide between the water molecules as well. So after a while, you're gonna watch that the water appear clearly, which means that the salt completely or the sugar completely dissolved. It now is hiding between or hidden between the spaces of the water molecules. So what would happen if you add another extra spoon of sugar to the same solution? Okay, it will dissolve. Okay, also, if we add a third extra spoon, so in that situation, you're gonna find that there is still some amount of sugar at the bottom of the cup and they don't dissolve even after stirring, they still not dissolving. Okay, so regarding to your eyes, it appears to be a static situation in which there are some particles settle down or they just found in the bottom, they cannot dissolve. Okay, but in actually or in just microscopic level, it's a dynamic situation here. We call this the dynamic, or we call this equilibrium. We reach the equilibrium or solution equilibrium. What does it mean? Simply, in the first case, already the water particles, they have a lot of spaces between them, which allow sugar to dissolve between these spaces. Then once we add the second spoon of sugar, we still have some spaces, okay, between water that allow extra amount of sugar to dissolve. It's okay. But at that point, okay, there is no enough spaces, okay, between the particles of the water. The spaces actually is completely filled by the smaller particles of sugar. So no more spaces. In that case, we describe this solution as saturated solution. That the solution which actually all the spaces between the solvent particles are completely filled by solute. So no more spaces for more solute. In that case, that means this sugar will not dissolve. No, actually we have here a dynamic process. Some of that sugar will break down and dissolve, but as it just dissolve and just get in a space, it take the space of another dissolved particle which is gonna recrystallize and fall down. So that's why for the naked eye or the just on eye level, it appears the same amount of sugar. It doesn't change. Yes, because the moment in which one sugar molecule is gonna break down into smaller particles, there is another one that is recrystallized and fall down. That's why we put a solution equilibrium. Equilibrium, that means the rate of dissolving substance is going to be equal to the rate of recrystallizing of another one. So here, that's how that's happened, guys. So let's look at this diagram. This okay figure, this graph here, guys. Actually, this graph represents you the amount of substance that could dissolve. For here, we have the sodium acetate, okay, which is going to dissolve in water. So we could observe that the sodium acetate, as we keep adding, it's able to dissolve, and dissolving rate is already happened. Okay, so until that point, we could describe the solution is unsaturated, which means there are still spaces between the particles of the solute, the solvent, which allow solute to dissolve in. So, and that means in that area, okay, in that area, already the solvent could carry or could provide more solubility or more dissolving of the solvent. But here, starting in the area B, from that point, now all the spaces between the solvent particles is completely filled by solute. So the solution turned to be saturated. It doesn't support any dissolving of the solute anymore. So here, like this, you could find that the water, okay, or the water could carry ability, or that's represented, could get here solubility equal 46.4 gram for each 100 gram of water. That means that's here the maximum capacity that the 100 gram of water could carry of that substance. Of course, it may differ from substance to another regarding to the size of the particle that form it from the solid once it dissolve. Okay, so like this, we could find the difference between saturated solution and the unsaturated solution. Saturated solution, the solution which contain the maximum amount of dissolved solute, and that means it cannot allow any dissolving anymore. Okay. While unsaturated solution, the solution that contain less solute, that means there is still spaces between the particles of solute of solvent that allow more dissolving of solute. That's the part which we're gonna step at, guys. Next time, inshallah, we're gonna talk about the super saturated solution and the solubility values. Okay, and then we're gonna find difference between or comparing between ionic compounds in aqueous solutions and the non-ionic or the covalent one. So if you have any questions, study this part from your textbook carefully. And if you have any question, I'm waiting for your question next time. Thank you and goodbye.